Hello everyone. I'm Andy, an instructor at ThinkMo. Currently I am teaching the CCIE course. Starting today I will share some CCNA, CCNP, CCIE related technologies with you. The topic of our lesson today is how switches forward data. It relies on something called a MAC address table for data forwarding. First, we need to understand what is the MAC address table. It is a data forwarding table on the switch, which maintains the normal data forwarding of the switch. Okay. We need to explain the following two aspects about the MAC address forwarding table of the switch. The first one we need to know the composition of the MAC address forwarding table of the switch. It mainly contains three major elements. The first is the MAC address. The second is VLAN. The third is interface of the switch. First, let's explain the MAC address. MAC address, we also call it hardware address or physical address. Why do you call it that? Because it is recorded on the network card chip. Network cards usually exist on our network devices. There may be one or more network cards on a network device. The MAC address is recorded on the network card chip. What is the function of this chip? It is the identity for the network card. Is a unique identifier. Therefore, the MAC address has a characteristic that it is unique and cannot be repeated. Okay, this is the first element. MAC address we mentioned. The second element is VLAN. What is VLAN? It's called virtual LAN. Virtual Local Area Network. So what is a virtual local area network? Let's briefly understand. It is used to identify whether the interfaces on the switch belong to the same network. Can be understood like this. In general, all interfaces on the switch belong to VLAN 1. Okay, this is what we call VLAN. The third is what we call the interface of the switch. So what's up with it? It usually refers to the connection interfaces to our end devices. Usually, these end devices are connected to our switches to achieve a concentric. This is the three major elements in the MAC address table of the switch. Next, the second aspect. It is the way to obtain the MAC address table. It is mainly divided into two ways. The first is through static manual configuration, the second is called dynamic breaking acquisition. First of all, what is static manual configuration? Static manual configuration is that we manually configure on the switch. Combine the three elements mentioned above. MAC address VLAN interface of the switch. Connecting the terminal device. Tie them together. This makes it possible to form a MAC address entry. Then dynamic automatic acquisition. It also combining three major elements. First, the terminal device we mentioned. Once the data is generated, interface to switch. The switch will automatically record this interface, the MAC address of the corresponding terminal device. This is what we call dynamic automatic acquisition. Of course, there are also three elements. It is the MAC address of the terminal device we mentioned, plus the VLAN to which this interface belongs. The default is VLAN 1. And this interface of our switch. Here are the two ways. We've mentioned access. In this process, static manual configuration. We usually call it static. Dynamic automatic acquisition. We call it dynamic. Next, we will experimentally to show what is static. What is dynamic? Okay. I have one switch here. The two PCs are PC1, PC2. First we open the switch. Then we renamed him. Take a look at what our MAC address representation called display MAC address. Now there is nothing in the MAC address representation. Next we put the head here. Then we manually configure it with a MAC address representation. MAC address is bottom. Then we just configure the 0000, 010203 as well, followed by the interface of our switch. Let's say this is G0-0-1. This is G0-0-2. We tie G0-0-1 to it. And the VLAN to which it belongs is VLAN 1 by default. Next, let's pass the display MAC address. Take a look. Now we see this one. Static representation. Where do you see it static? Tape study indicates that his type is static. Then port. VLAN to which port 001 belongs and MAC address. This is written in our hands. Static configuration. Later we will talk about what is called automatic learning or dynamic acquisition. In this process, assign an IP address to PC1. Say 1.1.1.1. Mask 24 bits. Apply it. PC2 also assigns it an IP address of 1.1.1.2. The mask is also 24 bits. Apply it. Then we use PC1 to pin in PC2 1.1.1.2. Now you can see that it's working. Then let's check it through the display MAC address. In the entire sub-representation of a MAC address, we have included 3 entries. One is our manual static just now. Such a representation of configuration. With this MAC address entry, there are also 2 MAC address entries. It's us through automatic learning. Through the switch. One is 3CE3. One is 35B8. In order to facilitate the identification of the previous things, we will not look at them again. First we open PC1. See what its MAC address is. 3CE3 right, no problem. PC1 corresponds to my MAC address. Then the VLAN is VLAN 1. The port is of type G0-0-1. PC2 is 35B8. Take a look at this. The VLAN corresponding to 35B8 defaults to VLAN 1. Corresponding port G0-0-2 type. Then here are our 2 MAC address entries. Next, if my PC1 produces a data when sending to PC2, first PC1 will send a data. Reach my switch. Then my switch will look for a table like this, called MAC address table. View the corresponding address in the MAC address table. PC2's MAC address entry, or the MAC address of PC2. Then we see the MAC address of PC2 is 35B8 below. Find the VLAN it corresponds to. Then find the interface corresponding to this VLAN G0-0-2. Send this data from G0-0-2. After sending, my PC2 can receive such a data. This is the data conversion of the switch. So the switch relies on the MAC address table forward data. This concludes our sharing today. If you have any other techniques you would like to learn, welcome to leave a message or private message me. If you are interested in my class, hope to like, share, and subscribe. Thanks. See you next time.